Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to our presentation session. In this presentation, we are going to talking about full wave rectifier circuit. I am MD Zahidul Islam and my other group mates are MD Shahin Ahmed Noyan, MD Omar Farooq Dolon, MD Shah Aziz and MD Shuzan Mahmoud. Here we are going to cover these topics that is shown in our display. Now, what is rectifier? A rectifier is an electrical device that is made of one or more than one diodes that converts the alternating current into pulsating direct current. And what is rectification? Rectification is the process of conversion of the alternating current into direct current. Now we are going to talking about types of rectifier. There are two types of rectifier. And one is a half-wave rectifier and another is full-wave rectifier. A half-wave rectifier is a circuit that converts the positive or negative half cycle of the input AC signal. And on the other hand, a full-wave rectifier converts both positive and negative half cycles of the alternating current into direct current. It provides double output voltage compared to the half-wave rectifier. Now I am inviting MD Shuzan Mahmoud to continue this session. Thank you.
Thank you, MD Zahidul Islam. Now I'm talking about full-wave rectifier. There are two types of full-wave rectifier: bridge rectifier and center tap rectifier. Bridge rectifier. A bridge rectifier uses 4 diodes to convert both half cycle of the input AC into DC output. Bridge rectifier. In this type of rectifier, the diodes are connected in specific form as given below. In this circuit of bridge rectifier, when we are using AC source, then we are supply AC source, 2 diodes are forward and 2 diodes are reverse. And when we are apply positive half cycle, 2 diodes are active and 2 diodes are cut off. But our load are same directional. When we are negative half cycle, use 2 diodes are same. 2 diodes are forward and 2 diodes are reverse. But our load remaining same directional. Now I am inviting MD Omar Farooq Dolon.
Thank you. Assalamu alaikum. I'm Mohammad Omar Farooq Dolon. Now I will explain the working principle of full-wave bridge rectifier. Here, during positive half cycle of input signal, diode D1 and D2 get forward bias and diode D3 and D4 get reverse. So current flows through diode D1 and D2 and we get this portion of input signal at load. During negative half cycle, current flows through D3 and D4 as these two get forward bias and other 2 diode D1 and D2 get reverse. So we get this half cycle at output. For both half cycle, current flows in same direction through the load resistance and we call this as pulsating DC because though direction of current is same for both positive and negative half cycle, but its amplitude changes its value simultaneously. Thank you. Now I am inviting Shahin Ahmed Noyan.
Thank you, Omar Farooq Dolon. Now we are in simulation circuit of this rectifier. This circuit simulation our needed 3 main elements: diode, AC signal or AC supply, and load resistor R2. We are used in this AC supply V1. This supply V of 0, VDC 0, and V amplitude is equal to 10 volt and frequency is equal to 1k hertz, and we are uses 4 diode D1, D2, D3 and D4, and we are one load resistor uses this name R2, this value 1k. When we are supply half positive cycle, then this time D1 and D4 forward bias and D2 and D3 reverse bias. This time we are getting output half positive cycle and when we are supply negative half cycle by V1, this time D1 and D4 reverse biasing and D2 and D3 forward biasing. This time again we are getting a half positive cycle. We are total full positive cycle, potentially getting output. This is our output. We are simulation using PSpace software and ORCAD 9.2. We are showing our output full wave rectifier first half cycle for positive half cycle and again half cycle for negative half cycle. This is our full half cycle simulation output of this rectifier. Thank you. We continue MD Sahaji's.
Thank you, my previous speaker, MD Shainam, for giving me a chance. Now I'm going to talking about advantage, disadvantage, and application of this rectifier. At first, I'm talking about advantage of this rectifier. The most main advantage of this rectifier, the efficiency is higher than the half-wave rectifier. Another one, the DC output signal of the full-wave bridge rectifier is smoother than half-wave bridge rectifier. In here, we should understand why the output signal is smoother than half-wave rectifier. For understanding it, we know about what is the ripple factor. And ripple factor is defined as the RMS value of AC component with ratio of value of the DC component. For this value, the IDC equal to 63.6% of maximum current. For this reason, when IDC is equal to 0.636 of IM, that's why power loss is more less than half-wave bridge rectifier. And that's why we get more smaller output wave from the half-wave bridge rectifier. And another most important advantage of full bridge rectifier, that is output frequency is twice of input frequency. In mathematical terms, we call it F not equal to 2 into Fi. Now I'm talking about the disadvantage of full wave bridge rectifier. We know that in full wave bridge rectifier, two diodes in series conduct at a time on alternate half-wave cycles. This creates a problem when DC voltages are required, and that's why it leads to poor voltage regulation. And another most disadvantage of the circuit, that is internal resistance drop. We know about the two diodes in conducting the series on alternate half cycles for these two diodes, and the internal resistance drop is twice than the center tap or half-wave bridge rectifier. I think it is the most bad effect for this rectifier. Now I'm talking about the application of this rectifier. In our regular life, we use uninterruptible power supply that's convert AC to DC. In this circuit, we use full wave bridge rectifier, and as well as our every home theater, our home appliance, we can use full wave bridge rectifiers as LCD, LED monitors, TVs monitors, and everything. And recently, Tesla company, the car alternator to sense the batteries during charge, for this working principle, they are used full wave bridge rectifier, and this is the most significant uses for at this level of at this era. And that's all our presentation. Thank you very much for staying with us. Assalamu alaikum wa rahmatullah.
And thank you all members, our other presenters, our 5 members, our group mate. Please self-introduce, name and ID. My name is Sain Ahmedan. My ID 172005.
And I am MD Zahidul Islam. My student ID is 172002.
Hi, this is MD Shah Aziz, and my identification number is 172013.
I am Muhammad Umar Farooq Dolan. My student ID 172012.
This is MD Shuzan Mahmoud. My ID 172091.
A big thanks, our group mate. Thank you.
And thank you very much, MD Shahin Ahmed Noyon, for dedicating your time our presentation. Thank you very much. Thanks a lot.
Thank our again thank our groupmate and again thank our teachers.